So this will be a quick review of vectors, resolving them, adding them, putting them back together. Remember, everything comes from trigonometry. So right triangle trig. And I also will refer you back to your equation sheet up at the top. It has this stuff. So if I have, this is the hypotenuse over here. Call it hypotenuse, and then across from the angle we get the opposite, and next to the angle we get adjacent. And so from this we can build some trig ratios. We have opposite over hypotenuse, and opposite over hypotenuse is sine. So sine theta, opposite over hypotenuse. And what we want is we want to get everything in terms of the hypotenuse. So if I multiply that across, I get the opposite is equal to the hypotenuse times sine theta. I can also relate the adjacent to the hypotenuse through cosine. So cosine of theta is the adjacent over hypotenuse. I multiply this over, so the adjacent is the hypotenuse times cosine theta. We also have tangent. So tangent would be opposite and adjacent. So tangent theta would be opposite over the adjacent. And for this one, we typically will use tangent to figure out the angle. So to solve for the angle, what we do is we do the inverse on the other side. So it's inverse tangent of that ratio. And so when you open up on your calculator, you'll see when you open the trig functions, you'll have like sine, cosine, and so on. Right underneath it, you have the inverses. And so you'll use that one, inverse tangent. All right, so what does this have to do with vectors? So remember that a lot of the quantities that we talk about, velocity, acceleration, force, these are all vectors. And so we do something called decomposing. So we take a vector and we decompose it into x and y components. So we're going to get vector components is what we call them. So suppose I had let's do a velocity. So this is my actual vector. So I have some velocity in this direction, whatever that is. And then some angle, theta. Then what we want to do is we want to figure out how much velocity is acting in the x direction and how much velocity in the y direction. And so we would get this velocity in the x and velocity in the y. And these are called components. These are what make up the vector. And so you can see from the trig, what we're looking at is our adjacent and opposite sides. And so we've already kind of laid out what they're going to be. But now we have it in terms of the overall velocity instead of the hypotenuse. So in this case, we would have, Vx, the velocity in the x direction, is going to be v, the magnitude of the velocity, times cosine theta. And then the Vy component is opposite the angle, so that's the sine. So Vy would be V sine theta. Now keep in mind that whether it's cosine or sine depends on where the angle is. Because if I had, an angle up here, then this would be the opposite. So in this case, Vx would be V sine phi. So Vx would be V sine of that angle, because it's in reference to this angle. And then Vy would be V cosine of this angle. So it depends on where your angle is, whether or not it's cosine or sine. But it's always the magnitude. Don't forget the magnitude. And this works for any vector that we're talking about. So we could also do this with force. Just to run through a force example real quick. If I apply a force this way, then I'm going to have two components on it. I'll have the force in the x direction and force in the y direction. And if my angle was here, then my force in the x direction. Let me write it down here. So this would be the force, the overall force times cosine, because it's next to the angle. It's adjacent. And this one likewise would be force sine theta. And so that's decomposing. So we break it up into pieces. Why would we want to do that? So one of the things that we do is we can add vectors analytically. So if I had a vector, we'll call it A, and then I add vector, B, and then I add vector C. So I can add up these vectors. This is, graphically it would be head to tail, so you kind of know that it's going to be from here all the way up to here. That's going to be my resultant vector, is this yellow one from beginning to end. But we want to be able to actually calculate it. So what we do is we break all of them up and we add just the components. So what I would do is I would find AX, all of the X components. This would be BX and CX. And then I'll go back and we'll do all the Y components. So we get AY, BY, and CY. So what we do is we're going to add up all the individual pieces. So the resultant, this one, the resultant in the X direction is going to be AX plus BX plus CX. And the resultant Y component, or the Y component of the resultant, is going to be AY plus BY plus CY. So what you can see is if I slide these down, so if I slid this down, I would get BX right here. And then CX would be right here. So that's BX and CX. And then we can move AY over here. That's AY. And then BY would be here. So you can see what I've done is this is just a big right triangle. So we just add up the pieces. So we'll add them up. And then to get the magnitude, so that would tell me how far this way and how far this way. To get the other side, that's Pythagorean theorem. So then the Pythagorean theorem says that r squared is going to be rx squared plus ry squared, because those are the sides of a right triangle, this big right triangle. And so the resultant, the magnitude, is the root of the sum of the squares. And that's how we put it back together. So not too bad. Let me do an actual example. We'll put some numbers. So I'll just do 2. So let's go this way, and then we'll go up. You know what, let's do 3, and then we'll come down. Just so you see how it works. So I know that the resultant is going to be from here to here, but I want to know actually how much. So let's make up some numbers. So let's say it's 3 this way, 2 this way, do 1 and 2, and then this one goes over, let's say, 3 again, and we'll do 1 here. Okay, so to add these up, let's do A, B, C. So the resultant in the X direction would be AX plus BX plus CX. So it's going to be 3 plus the BX, 1, plus CX, 3. So we get the resultant is 7 in the X direction. And then in the Y direction, we'll get 2 plus 2 minus 1. Why minus? Because it's down. So we get 2 plus 2 is 4 minus 1 is 3. So that tells me how far over and how far up. And then to get how long the actual vector is, we would take the root of 7 squared plus 3 squared. So whatever that comes out to be. So anyway, that's vectors. That's dealing with vectors and breaking them up. When I get to examples, you'll see how we apply this.